Okay. Okay. Okay, so I start. Please take out your assignment. Okay. If haven't do. Oh, haven't do. Huh? You did 3 questions. Oh, okay, okay. It's fine. You again never do. Megan, what happened to you? Rubbish. What never do? No time. This is the wrong one. We have to talk about the topic before. Take it out, please. Put it on the table. Start. Okay, so I start. Okay, it's all right. If you haven't do, let's do it now. Okay, bias maker. It's okay. If you haven't do it now. After this, I will airdrop the solution to you. Okay. Whose is this? Oh, this is a. Oh, no, what's this? This is a kidney, right? Kidney? Liver? I thought we got two livers. Okay, okay. Whose is this? Miss Chin one, is it? Oh. Okay, so let's go to question 1. Better where your pants are from now. You understand? So many times I call you already. Then dry lah. Get a fan, dry yourself. Get a fan, dry yourself. Or what I do last time, I go to the aircon room and sit down there for a while. Then cool myself down. Try lah. I know weather hot, but respect is respect. When you wear the correct attire, it's respecting the occasion. Oh, okay. It's not about following rules. It's about your own well-being. You look at the Japanese when they go for, they all wear clothes. You see saw before? Okay, so let's go to question 1. Question 1, you have modulus F equals to modulus G. That is basically F equals to G or F equals to negative G. Okay, F equals to or G, F equals to G, F equals to negative G. Okay, so that's why you solve, you have X equals to 4, X equals to 2 there. Okay, give you. Okay, can I? Yes. You don't need, because it is protected. Because there's a modular sign. So you remember, okay, so you see a question. This is the question, right? This is guaranteed. It doesn't matter. Because modulus 2x minus 3 is always more than equals to 0. No matter what x is. No matter what x is. So therefore, there's no need to consider any restriction. Oh, okay. The one that you need to consider is question 1C. Okay. So let me go to 1C. 1C also pretty okay. So you can see equals to 3 or negative 3. Can you solve it by squaring it? Squaring. For 1A. You might get extra answers. So usually I tend not to square, because if I square, I will get extra answers. So if I get extra answers, I need to check extra answers. Yeah, I think if you square, you might get more, right? More than what you asked for. Then end up you need to reject those answers, which is troublesome. Okay. Even though you got do, check mark. Sit closer to your table and mark. Hey, where's your? Okay. Why don't you sit closer to the? Why do you sit? Is it on purpose? Is there a reason? Honest. You cannot put your table. You cannot put your. Joshua have to carry. No. Bring the table to you. Don't bring yourself to the table. Okay. Okay. I go to 1C. So if you look at 1C, right? Now you look at 1C, okay, now there's a difference. The cosecant has no protection. There's no modular sign. That means, right, it tells me that this cosecant has to be more than or equal 0. Okay, so far? So this tells me that you will need cosecant x to be more than equal 0 because there's no modular sign around it. So there's a difference between this and part A. Okay? Can so after that, I will start in and check. So you see secant x equals to cosecant, sequence equals to negative cosecant, right? Okay, from here, I came to this step. Do you understand why? Cannot? So what I did is basically, I just change cosine, cosecant to 1 cosine. That's what cosine. Flip for right hand side. Flip to cosine equal to sine. Cosine equals to negative sine. Okay, yes. Which one? The blue box, you don't get it. Okay, so from here, you understand how I got from this step to this step. That's what. That's the blue box. That's the blue box. That's the blue box. There. And that's the blue box. Okay. So here to this step, divide by cosine on both sides. You get tangent x equals to 1 or negative 1. After that, you have 4 answers. 1, 2, 3, 4. These two will be rejected. Why? Because cosecant 5 pi over 4 is negative. This one is also negative. Okay? So you must remember that because of this question, right, you need cosecant to be positive, non-negative, more than equal 0. So if you found these two values, you will see that cosecant 5 pi over 4 and 5 pi over 4 reject, 7 pi over 4 reject. That's why you're left with two answers. Okay, ma? You don't like or do? Or do for everything? Okay. Those that need time to do, you copy down the main steps or you copy down the answer. Okay? You kind okay? Easy lah. Okay. Okay. So okay, Mitra okay, One okay. Are you with me? Are you at the assignment or are you on something else? Okay, very good. You understood the assignment, huh? Mitra okay? Never do. You're doing now. They do together. Okay? Very fast. So we Megan, Fires do together. Can do together. Quite quick. Okay, I slowly go on. Okay, may I go on? Question 2. Okay, question 2. So some of the notes I wrote down is this. Okay, you said this is the question. This is the question. Okay, whenever the question has endpoints, you see they ask you to draw from 0 to pi. You need to make sure that you need to make sure that you have endpoint also. So just take a look at these guys, 0 and pi, right? You need to make sure that you have 0 and pi. Okay, very simple. Look at the marking scheme. They give you 1 mark for endpoint. Okay, in senior high, we call this domain. Okay, when they define a stretch of values for x, this is called domain. Yeah, the x values which they define the function, we call this a domain. So if the question has a domain, you need to label your endpoints. You need to label your endpoints. And so far, there are two task pens. Okay. What happened? Yes, Mitra? What happened? Huh? Okay. No, later I need this. Okay, can I heard this one can cure hiccup. So next, I want to draw 0.5 minus sine 2x. Okay, so because I know that modulus f is the same as negative fx, correct? Correct? So can I say that 0.5 minus sine is the same as sine minus 0.5? Like that easier to draw ma. Like that easier to draw ma. So I will use this, it's easier to draw. This is easier to draw. Or because why sine 2x? Sine 2x I know it will look like this. Sine 2x will look like this. Correct? Sine 2x minus 0.5 will look like this. Correct? So if I do a modulus, then this part is gone. Come here. This part is gone. We'll go up like that. Okay? So you can see that this part is being reflected. This part is being reflected. Okay? Can Alison? Can I? Okay. After which, what else you need to do? You need to label the x-intercepts turning point in exact form. Meaning, you need to find out pi over 12 and pi over 12. So guys, when you draw your graph, please make sure you try to use pencil. You label your intercepts turning point. When in doubt, you put coordinates. Okay, some of you will ask, is it put coordinate or just put pi over 12? If you are in doubt, just put coordinate. Okay, I need your graph to be as detailed as this. Got this point, got this point, got this point, got this point, got dotted line. Okay, you either put the coordinate or you put dotted line. Dotted line. Okay? Okay? Why is it pi over 12? Why is it pi over 12? Because you equate this to 0. So how do I get pi over 12? I equate this to 0. I equate this to 0, 0.5, x equals to pi over 6 or pi over 6. So, okay? Okay? Megan, on task, on path. Huh? Okay, Can? Okay, I know it's very boring. Please stay awake. Yeah, don't sit. Don't put your head on the desk. Once you put, you will sleep. Okay. Can I just go around? Everybody got put all the labels on your very good. See your what? Very good. Can I go around and see your graph? Your graph. That's your graph. That's your graph. Hey, hello. Where are all your this one, right, is 2 points. Equate this to 0. Equate this to 0 to find this 2 points. Okay, use a ruler. Please, for God's sake. Draw a nice one. Okay, yours looks is right, disproportional. Okay. 2B, I think 2B I think it's okay lah. Nothing. What are you all two doing? What is that? What's that? Muffler. This looks like the snow muffler, is it? Give me, confiscate also. Timothy, pass to me. Confiscate. Where is he from? What is it for? Okay, so fx, huh? Okay, so you sketch modulus fx. Here again, you see that for this graph, 1 mark is for shape, 1 mark is for asymptote. So here, can I put the intercept? Yes. Y intercept? Yes. Yeah. X intercept, can I? No, cannot. It's not given. But dotted line, you need to reflect. Okay, it's not an L. What L? L? You write an L, you get an L. Yeah, no L. Okay, so this one, you need the L shape. Not L. It's like a long graph. Then it's dotted line. So make sure you write down the dotted line. Yes. Yes. Try to label the equation of the asymptote if you can. Okay, can . 自动 give you one. In Chinese, they call it 定情之物. Okay. Token of love. So, question 2, okay? Okay? Why? What's the joke? Huh? What's the joke? What's the joke about? Serious? It's being recorded, you know? Maybe I do this, I'll get more views. My subscriber very sad. Okay, so question 3 part 1. Okay. Megan, okay, done already? Megan, done already? Yes, so done already, huh? Okay. Yes, so question 5, just take note, there should be 2 intersection points. So check, I think you only got 1. I should see 2. Okay. Question 3. Okay, 2x minus 4. So you just draw y equals to 2x minus 4 first. Then you reflect. Okay. Just reflect the bottom portion about the x-axis. You reflect the bottom portion about Joshua. Pay attention about the x-axis. Okay. So this is how the first line looks like. Any issue? No, right? The part that's below you reflect upwards about the x-axis. Okay, 4 words you can ask. Is it possible to reflect about y? Possible. You can go and Google in the graph, how it looks like this modulus x-axis. But you only learn in senior and graph. Let's see. Okay. Possible. But senior higher. Yeah. Can Shut up, Jaden Lloyd. Can Is it okay? Is it okay? Okay, let me go on. 3 part 1, okay, Okay, I go to 3 part 2. Question 3. Question 3. This is the question in case you need. Okay, so gradient m pass through 0, minus 1. So what I want to do is I want to let if you think about it, if I gradient m pass through, that means basically the equation is y equals to mx minus 1. Okay, this is the gradient, this is the y-intercept. This is the gradient, this is the y-intercept. Okay, so if m is equals to 3, then the equation is just y. If m equals to 3, the equation is 3x minus 1. Okay. So now, if I want to find intersection, what do I do? Basically, I will solve simultaneously, right? If I'm going to find, I will solve simultaneously. So, solving simultaneously, you can see 3x minus 1, 2x minus 4. Okay, I solve them side by side. Okay, this is to help me to find the intersection points. To find the intersection between 2x minus 4 and y equals to 3x minus 1. Okay. After which, I get two coordinates, 1, 2, negative 3 and 1. You will find a negative 3, you need to reject. Okay, again, the modality of rejection is by substitution. You sub into the left hand, sub into the right hand side, you find that the two answers are different. Okay? Yes. Try to. Okay. And then if possible, try not to square both sides unless really desperate. Squaring both sides always give you unwanted values. Okay. And so this is question 3 part 2. I will wait here for a while for those who are doing to catch up. Yeah. No need. Part 3 is very similar. So if you look at part 3, anyone still doing part 2? Yes, I wait for you. You're still part 1. You're part 2. Okay? Part 2. 慢慢来，慢慢来。equate both sides and solve simultaneously. 再 solve 很好，不用担心，现在 on the spot 是可以做的啊。Because okay, there's no square, there's no power 2, right? Discriminant is only for quadratic. Okay, so guys, I'm going to go through part 3. Okay, so part 3 is the exact reason why I'm good. So let me highlight this dot. This dot. Let's call this the pivot point. Okay, I'm not teaching physics, but this is similar to the golf question. You remember the golf question? Question 5.6 inside the notes. Okay, okay, pay attention a lot. Pay attention, can you still you see a reading space? You should do so tight. There's no person in time. Okay, so this here, this slide, if what's the gradient of this line? 2. So the basic whatever happens, 0, but this line is still, this is a given point. So I put my piece here, this line will pivot, and this when gradient is 2. When gradient is 2. Guys, pay attention. When gradient is 2, also pay attention. When gradient is 2, how many intersections? 1, right? So when gradient is less than 2, 2. Less than 2, less than 2, less than 2, until here, gradient is half. When gradient is half, how many intersections? This is 1. This is 1. In between is 2. How do I get 0.5? Okay. This is this point here is 2, 0. This point here is 0, minus 1. I find the gradient. Is it okay? Okay. A similar question was done in AML as well as the golf ball question. Golf course question. Yes, sir. Actually, no need to write anything. No need to write it. Yeah. So here this is the word. But basically, if you see the marks, E1, correct endpoint, 2 points. If you got 2 points, you can do 1. So this is the final answer. Okay. And yeah, every year like to test. A lot of schools like to test this. Petra, would you like me to explain it, judging from your I think you sound like you want another explanation. So this is the line. This is mx minus 1. This is fx minus 1. The red line is fx minus 1. Okay, so if n is 2, how do I get this line? Okay, so you see here, black color line, right? What's the gradient? 2, right? So this is 2, can I say the parallel is 2? Because if it's parallel, right, you will only intersect one time. Even if it's not parallel. Okay, so if it's slightly steeper, right, yes, it will also be intersecting at one time. But this is a boundary. You see, if anything, it must pass through this point. This is where gradient is 2, right? Any position from this line to this line, right? Okay. Because this point, 0 minus 1 lies on this line. 0 minus 1. Okay. Determine the set of values for n for which the line, this line, and this point, this line plus this point, right? So no matter how I change the n, now because this point will always lie on the line. So if I'm pivoting, the gradient will change, but this point will always stay. See my hand, my feet started changing. Right, but the line will constant. What about the gradient beta? Same. Okay, so now if I manage to convince you the gradient is 2. So now if this is 2, a parallel line passing through this point, there will be gradient. The gradient is also 2, they will only intersect one point. Yes, so steeper we also don't count. But I'm interested in this as the boundary line. So I'm looking at from here to here. I'm looking at it. Here also we don't count. Here definitely is less than it. There's only one solution. But from here onwards, if I go down, it's 2 solutions. Okay? And I'm showing you like where to find your answers. So the answers start from the line of interest, which is here. This is gradient 2. This is gradient 2. If I start to bring my line down, I will intersect 2 points. Okay? If I start to bring my line down even more, this blue line here, the gradient is R. So what I'm going to tell you is between 2 and R. That's your area of interest. Steeper than 2, no point, nothing. You know that it's 1. Less than half, even worse, 0. Okay? So the way to do this question is really by pivoting your pen on the line. Okay? And sit properly, use your green pen, sit up straight. If you got time, try to do the AFL yesterday. Or you finish already. Okay, later we do, okay? Okay? AFL 3. Huh? Huh? JV also here. No, JV, you get from Sit Hong. Okay, can Anyone else? Don't worry, just ask until you are satisfied. Ask until you are satisfied. Okay, Okay. So now, part 4. Is it part 4? No, sorry. Question 4. Can I go through question 4? Okay, so question 4 again. What do you see here? Negative 3 and 5, they are endpoints. Negative 3 and 5 are endpoints. Okay? Negative 3 and 5, they are endpoints. Okay? Can you see the endpoints? So negative 3 and 5, you need to put down the endpoints here, and you need to put open circle. Can you please take note? This gets you 1 mark. Can? I hope you put open circle. Please remember, guys, I say again, open circle means not included. Well said, yeah. So that's why, because you see negative 3 and 5, right? These endpoints are not included. But I need to write them in as open circle. They are not part of the values, but they are in open circle. Okay, can you check Joshua's graph? Did he include the endpoint? Yes. Closed circle is very equal. For example, like this, I use closed circle. Understand? Okay. Ariel, Isaac, Chloe. Closed circle is like point. But closed circle is more like I use it for number line. I use it for graph. Okay, let's say for example, if let's say the domain is x more than equals to 3. Then at 3, it will be a closed circle. It will be 3,6, for example. A bit bigger because I want to label it as an endpoint. I want to show you that, see, I want to show you that this is my endpoint. I end here. Okay, all right. Anyone else? Yes. Which one? So the x intercept, huh? Which one? The pink color, what you mean? Don't have color? Oh. Is it because? Yeah, never write. Supposed to have. Thanks for highlighting. So what is the x-intercept? Can anyone tell me? Is it 2 and 2 and 3? Thank you, dear. Huh? He's not talking about me. I can hear it so well. For a mother, I tell you. Okay. So after that, please remember, okay, when you draw your point shape 1 mark, endpoint 1 mark, x-intercept 1 mark, turning point 1 mark. Please make sure, especially the boys. No offense, the boys always more careless when you are drawing your graph. Okay? Can? So make sure that when you draw your graph, you make sure that you have your endpoints. Okay? Make sure that you have your endpoint, make sure you have your x-intercept. You go away already. Let's see you. Okay. Stay away, Stay away. Step straight. Okay? Okay, so next one. Okay, so now you see, okay, I need to solve this equation. So how do I solve? This is the same as looking at, this is the same as x squared minus x minus 6 equals to 1 minus 3x. Agree? So I solve both sides simultaneously. Okay, I can solve that. So if I solve them, if you just look at this, right? This is y equals to 1 minus 5x. Okay. This is the green, and this is the yellow. Okay, look at the intersection point. Do you think the intersection, the x is negative or positive? Negative. So if you find two values, guys, you find two values, right? So you find two values. That's why it gives you the reason to reject the positive answer. Okay, all? Then, yes? His eyes are closing. What happened to you? It's like I can blindfold him with the dental floss. Okay. Stay away, Joshua. So the question did ask us to draw the graph. Right? Oh, yeah. So that the question did draw the graph. So you're using the graph to help you to see where's your answer. How do I know that it doesn't touch? Minus 3 and 6. The left side yellow. Are you referring to here? Because when, okay, so this is y equals to, so this is just sketching a line. y equals to 1 minus 5x, right? Now, if x is equals to -3, for example, then y will be 1 minus 5 of -3, which is about 16. So when x is -3, y should be about 16. It will definitely not cut. You are sketching a linear line. 3x not 5x. Oh, sorry. 1 minus 3x. My bad. 3, yeah. So it's about negative. It's about 10. So this is 10. So you know that at the same x coordinate, right? Y is above the other. They will not intersect for sure. Okay, huh? Okay. For part 3, okay, when is modulus x squared minus x plus 3x plus 1, this basically means that same as asking x squared minus x minus 6 to be more than 1 minus 3x. If you consider this as a yellow and this as the green, do you want yellow to be above green or green above yellow? Yellow above green, huh? Okay, very good. So I hope that clarifies. Okay, where is my yellow above green? Yellow is over here. Green is over here. Where is my yellow above green? Where x is more than -1. Only define up to the value of 5. Okay, hey, why keep sleeping, Zan? Cannot. Zan, go and wash your face. One more time you sleep, you get out of my class. Okay? Can why I picked the? Oh, okay. Good question. Yes, I missed this out. Okay. Where is it? Okay. Or why I picked the positive, right? Why I didn't pick the positive? Because, okay, if you see, Ophelia, I'm going to try to view for right. Okay, this modulus, this portion, the modulus is equal to x squared minus x minus 6. Because fx is more than 0. This portion here, this guy is equal to negative of x squared minus x. Because fx is less than 0. Modulus of fx is equal to negative of 5. 可以吗? Cannot. That is why I take the negative. Yes. Thanks for mentioning this. I forgot to talk about it. Yes. So at this portion where it's modulus, right? The mod f is equal to negative. Okay. Stay away, Okay. Joshua, pay attention, stop talking about other things. Okay, for 4 part 3, x more than -1, is it okay? Yeah. Because the question is only more than, it's not more than equals to. Okay, can I? So you need to look at the question. Make sure you have your question first. This is topic okay, 4. Can I? Okay. So for part 4, I want to have one solution. Okay, so I'm equating this to k. What kind of function is k? What kind of line? Horizontal line. Very good, Timothy. Yeah, best answer. Horizontal line. Or y equals to k is a horizontal line. So if you are talking about this, right, one solution, it means that there must be y equals to k and the curve has one intersection. Is it okay? Or y equals to k and the curve has one intersection. So from here, guys, stay with me, Okay. That means when will I have one intersection? Here. Let's look at the yellow only. Look at the yellow only. Can you see from this part? or this area here, above the turning point, where K is more than 25 over 4. Each time, only one intersection. Okay? When will there be two intersections? When it's between 0 or 6.25. 6.25 is over here. You can see, this one, does it intersect? It doesn't. It's an empty point. So look at this portion here. One intersection, two intersections. This one, not counted. Okay? This is not counted. So you can see y equals to 25 over 4. How many intersections are there? Total 2. Y equals to 0. Y equals to 0. How many intersections? 2. Clear? Okay, I'll leave the rest for you to take a look. Okay, then I go to question 5. Question 5 also quite easy. Those that haven't do your assignment, you can literally do it now. It's pretty fast. Y equals to? Y equals to K, so Y equals to horizontal line. Y equals to 3. K equals to? K equals to x squared. Okay, so x squared minus x minus 6 equals to K. We are looking at first one. Y equals to x squared minus x minus 6. Second, we are looking at y equals to K. There are two equations. Okay, so the number of times this intersect will be the number of solutions you'll have. Y equals to K is a horizontal line. Y equals to J3, J2 you're looking for. Y equals to 3 solutions. You understand? Understand? Yeah, it's just a horizontal. So Ethan, look at this. Y equals to K. No, it's not this one. Y equals to 3, for example. Can you see? Horizontal line. Horizontal line, Hello, it's a horizontal line. Y equals to, I can rotate this around, you can see. Horizontal line. Can Huh? Come again? Come again? It was what? Inching. Glitching. Yeah, I know it's glitching. Every time there's most, it will glitch. Yeah, okay, Okay, So, now I go to 5 part 1. Okay, for 5 part 1, you need to take note. When the line here, you can see that their gradient is different. Their gradient is different. What does it say? That the left-hand side, if they are different, they will definitely intersect. And they may not intersect just once. So in this case, can you just check your two curves should intersect twice? If your graph only intersect once, that means maybe you never draw enough. Okay, so you need to intersect more. You need to, what are you looking at, punk? Okay, so yeah, what are you looking at? What? Is this even legal? You were cheating during the math test, you will look at people's face. Is this even legal? Now I feel a bit scared. So 1, 2, these two are the point of intersection. Clear? So when you solve, you will get -3, -1 over 5. Okay? Where does the marks go? Symmetry. Symmetry intersects. Okay? At the point of intersection you solve, you see you basically want the red to be above the blue. Okay? Now this 2 point intersection is -3 and -1 over 5, which is why this is the answer for 5 part 2. Standard question. Okay, what happened? You don't bully him, Yes. Can I go back to 4 parts here? between 6 and 6.25. Okay, so because I look at the curve, right? 6, you can see, okay, when it's 6, right? When it's 6, right? 6, right? Okay, y equals to 6 is here. There's 1, 2, 3 points. 6, no, you see 6, right? Is an empty circle. So that's why I never cut. Okay, Can, yeah, what's the second? Yeah, Zoe. So that's why I 6, it's only 3. Okay. Shh. Pay attention, please. Okay. So now 6.25, 6.25, you can see it's also up to 6.25. Okay, 1, 2. Okay, let me go on. Mitra, you say scroll down to where? Question 5. Top part 4. Okay, I just pause here a while. I look like a Mickey Mouse. Can you put your attention into doing the question or Joshua? For once. Wow, every class I go, I scold you better. Yes. 0 or 6.25. Why 6.25? Because when 6.25, right, this is the turning point, right? 1, 2, that's all. The left-hand side does not touch 6.25. That's why it doesn't intersect that. Okay? Anyone else? This question is quite tricky. It's quite tricky. So if you can do, good. Okay, yeah, it's really about the fundamental understanding of using a horizontal line, y equals to k, we better some. Okay, I hope you all took away the learning point. Okay? 可以吗? I know it's tiring, it's a Monday afternoon, but try your best to listen to me, okay? Can Tuesday. Okay, I go on. Question 5. Like I say, two modulus graph, V shape. If the gradient is different, you can see the gradient is different. The gradient is different. What does it mean? They are bound to intersect. So you need to make sure that you have intersections on your graph. If you only have one, that means probably you never draw it now. Okay, you never draw it now. Make sure you have two. Or 5 part 2, just equating them. Solving for the point of intersection, you get -3 and -1/5, which gets you the answer. Okay, question 5 pretty straightforward. Yeah, and I can do on the spot. No, he got stop already. Okay. The pressure. Is it okay? Can see? If you like, I can airdrop you the solution. Okay. Since I've gone through the whole thing already. So if I see you, I'll send you. I'll put it on Google Classroom today as well. In case you all see, I never share the videos. It's all being recorded. Okay, yeah, it's just all on YouTube. Please go there and search. Okay, Who is Cheers? Huh? No, no. Every of my lesson want to go toilet. Okay, okay. Jaden, come back. It's your task to help everyone fill water bottle. Jaden, please. Yeah, I don't see anyone. Do I send you all? Okay, I'm trying to airdrop you. No, it's okay. So I go on. Okay. So 5 part, yes. Because, okay, when is the grass, right? Huh? No. You're serious, ah? Okay, okay. You push it, push it. Wow, you're like. They are discussing how to go toilet in my class. Huh? Okay, careful, careful, Okay, slowly. Need to play some sad music when you go. Okay, so because if you look at the question, right? If you look at the question is you want to solve this less than this. Okay, so what are the regions of x for which 3x plus 2 modulus is less than 2x minus 1? Now, 3x plus 2 is the one that is in blue. This is the one that is in blue. 2x minus 1 is the one in red. You want blue to be less than red. Where is blue less than red? It's the part that's in green. Can you see? This region of x is where your blue is here, your red is here. That is why it makes sense to consider the point of intersection. I consider this point and this point. -3 and -1/5. Pay attention, Junkai, stop looking outside. Why? It's so hard to get your attention. You're like monkeys, right? Okay. All look here, all look there, all look there, all look there, all look there, all look there. All looking outside. Looking outside. You are students or no, not people in Changi prison. Okay. Prison is there. Junkai look until his mouth all open. Okay. So now I go to 5 part 3. 5 part 3, okay, 3 plus 2x, 2 minus x. How do I get to the final outcome? It's by so-called dividing by mod x of both sides. It's mod 3. Okay, this gets you to the answer straight. Okay, that's all you do. Not easy, because I look at the coefficient. Okay, so, hey, best friend. So after that, you take some time to do your correction, then pass on to Sidong. Okay, Sidong, okay? Sidong, you help me to collect from Wei Xiao, okay? Huh? You go to toilet, you saw the arrow? What happened? Yes. Luck, it's really luck. Like you look at it, I look at the coefficient. Right? How three becomes like 1/x. And that's hard. Yeah. It's just a technique. Okay. Because I observe the coefficient, right? Okay, see, from 3 comes 3 and 1/x, right? I observe the coefficient. 2x comes 2. Say 2 minus 2 1/x. Across, I'm dividing all by 1. That's how I see the pattern. Okay? Then what were you asking? What stapler is it? Oh, I thought you were doing sign language. Okay, Once you're okay, can pass to Sitong. You managed to finish. Okay, can okay, so let's come back to AFL. Can you take out AFL 3 now? Those who have not done the AFL, can you take out from yesterday? We are left with about 2 questions. Yes? Please take out your AFL 3 and take a look at it now. No, don't let the general ask it yourself. Ask Brandon, I'll go help you. Brandon, you should not say that. Teach him. Okay, can you all take out? What question are you all at now? Question 2. Okay, let's continue.